So in this video lecture we are going to talk about self energy. Self energy is defined as negative of work done by electric field in assembling the charges of an object slowly from infinite separation. What I actually mean is, let's say if I have to assemble charges on a hollow sphere may be conducting, non-conducting, whatever it is. Let's say if I have to accumulate some capital Q charge on this sphere, then what I'll do is I'll start bringing charges from infinite separation onto this sphere. Let's say at an intermediate stage, the charge available on this sphere is small q, and I'm trying to bring more dq charge onto this sphere. Then this dq charge will experience some repulsion force due to this positive charge q available already on the sphere. So I will have to do some additional work in bringing this dq charge up to this sphere. So this work of mine will get stored in the form of self energy of this hollow sphere. In other way, I will say that some electric field will be there, and that electric field will push this dq charge in this direction. And if I want to move this charge dq very slowly onto this sphere, then I'll have to apply some force. We can simply see that if the charge is moved very slowly, then this electric force and this force of mine has to be equal and opposite in direction. So the work done, we can say that the potential energy stored in this sphere is simply equal to work done by me in bringing charges from infinite to this sphere, or you can say that this is negative of the work done by electric field. So this was also the definition for interaction potential energy. So here we can see that this dq charge is also a part of this sphere. This is just a component charge of this sphere. So I can say that the self energy is simply the interaction energy of the charges available onto the sphere only itself, right? In interaction energy we talked about two different entities, two different charges, but in this case the energy is called self energy because the interaction is happening between this dq and this q, which are actually the part of this q, capital Q, or this sphere, right? So self energy is also some kind of interaction energy between these dq and this q, right? So I can simply state that the potential energy of this charge q, when this charge dq will be put on this sphere, will be k q dq by r. Kq by r is the potential at this point. Kq by r is the potential at this point P when the charge on the sphere is q. And if I put this dq from infinite, where its potential energy initially was 0 at infinite separation, now its potential energy after keeping or after moving this dq at this point P will become kq by r is potential of sphere and this charge dq. So this is the small potential energy of this dq, and I have to integrate this potential energy to get complete self energy. I can put the limits of dq, which is from 0 to q. So k by r is constant, q dq integration is simply q square by 2. So the self energy comes out to be equal to kq square by 2r for a hollow sphere. Hollow sphere can be conducting, non-conducting, but it has to be uniformly charged only, right?